probably familiar with this notation, y equals f of x. Let's get into what this really means. We're going to represent this as a graph, and x represents the horizontal displacement from 0 of something called an ordered pair. So we're going to have an xy pair. The x tells us how we travel horizontally from 0 to get to them. The y is the vertical displacement from 0. The y-axis is this up and down axis. When we get y as a number, we're going to take vertical steps. So if we look at a point like 2, 5, if we just type that into Desmos, it will graph it for us. When we see it put it at this place, let's see how we got there. We went over 2 horizontally because the x value is 2. And then we went up 5 because the vertical displacement from 0 is 5. And we wound up at the point 2, 5. How do we use this to represent functions? For each x in the domain of f of x, we put a point where the y value, the y coordinate, is given by plugging x into f of x. So suppose we were to try to graph y equals x squared. There are infinitely many points. We're not going to graph all of them. Instead, what we'll do is we'll take some values and we'll plug them in and see what we get. So when x is equal to 0, y will be equal to 0 squared, which is 0. So there would be a point at 0, 0. Similarly, when x is equal to 1, y would be equal to 1 squared, which is 1. I'll have a point here at 1, 1, and then I'll also have a point here at 2, 4, because 4 is 2 squared. Now, I'm not going to be able to do this for all of the infinitely many values in the domain. I'm not going to try to. What I need to know is something about the shape. Once I know the general shape, that it's a quadratic, and I know some points, I can graph it. If I have a computer, I don't even need that. The computer will graph it for me. But the way that the computer graphs it is by just creating lots and lots and lots of points. And the computer can do that really quickly. So it almost seems like magic. But what it's doing is the process that we did to create these points. It's just doing it for thousands of points that fill things in. So if I'm given the graph, I can answer questions about evaluating the function based on looking at the y coordinate of a particular x value. Since I'm given this graph of y equals f of x, it's zoomed in so that x is roughly between -1 and 1, and I'm asked, what is f of 0? To answer this question, I am going to look at x equals 0, which is on the x-axis, so I have a horizontal displacement of 0, and I'm going to go up from 0 until I catch what the y value is. At 0, I go up 1, 2, 3, 4, and I see that there is a point at 0, 4 on the graph, and that tells me that f of 0 is equal to 4. It's important to note, if all I have is a graph, there may be times that I can only get approximate information and not exact answers. As an example of this, I could ask, what is f of -0.5? To find that out, I'm going to walk backwards, and I see I have -0.4, -0.6, and x equals -0.5 is halfway between them. Then I look up or down from x equals -0.5, and I say, what is the y value? And it looks to me like it hits right at y equals 5. I see a point here that looks like it's right at -0.5, 5. So f of -0.5 will be 5. Now I ask, what is f of 0.6? So I can go over to x equals 0.6. Figure out where is the curve in the y direction when x is equal to 0.6. So I got 1, 2, 3, 4.5. Now I'm approximating. I don't know if it's exactly a half. I don't know if that's 0.55, 0.51. It doesn't matter too much because I'm allowed to say that I'm approximating. And as long as I say that, everything is good and people know what I. So when x is equal to 0.6, y, and there's a symbol we use for approximately equals, y is approximately equal to 4.5. And often that's good enough. I'm just going to be honest and say I'm not 100% sure. This is an approximation. F of 0.6 is approximately 0.45. Now we know how to determine f of a value from a graph.